Hey class, this is lesson 613, learning how to use the Pythagorean theorem. Just to get started here, let's talk about what the Pythagorean theorem means, and so that we can kind of have that knowledge in the background as we're trying to apply it to solving some problems here. If you remember, in symbolic form, it's a squared plus b squared equals c squared, and that's from a right triangle with legs of lengths a and b and a hypotenuse of c. And the a squared actually means the area of a square on side A plus the area of the square on side B is equal to the area of the square on side C. So this shaded area here plus this shaded area here, if I combine those two areas, I'll get that shaded area. So if you look at here, to find the missing area, look at the two smaller areas that make up the leg. That would be this one, and that would be this one. Now 9 isn't the length of the side here. 9 is actually the area of that square, and then the area of this square is 16. So that means the area, this green shaded area here, is the sum of those two. So 9 plus 16, which is 25. So go ahead and do the next one, see if you can figure it out. Pause right now. In this one, we have the two, we're missing one of the smaller areas. So the biggest area is 6.25. So we want to subtract the smaller area here. And we get 4 for that one. All right, so that's basically the Pythagorean theorem. Now, the way we use that, though, is different. We usually use it to find lengths. So, and here's an example. Here we have a leg of length 1 and a leg of length 2. So the area of the square on that leg, and we can just use this. So 1 and 2 are actually a and b here. So we can just do 1 squared plus 2 squared, and that should equal c squared. That's my missing side, c. And 1 squared is 1, 2 squared is 4. So c squared is 1 plus 4, which is 5. And then to find that 5, the way you undo a power of 2 is you take the square root. There's actually 2 square roots of 5, a positive and a negative, but since we're talking about a length, we want the positive one. So we say c is equal to the square root of 5. Now you could change that to a decimal if you want, but if you want to leave it exact, you could just leave it as the square root of 5. All right? So, and here's that example I just did. All right, now, sometimes you're actually given, I'm going to leave number 5 for you to do, and you can go ahead and do that now if you want. Pause here. Number 6, and if you think you know how to do number 6, go ahead and do that. But let's call this side B. So basically we're given A and B. We're not given B, so we're looking for B. And those are the legs, the two parts that make up the right angle. C is actually the hypotenuse. So if we substitute in here, we get a squared is the a part, the b we don't know, and the c is 25. Now if we square that, we get 49 plus b squared is equal to 625. Then we're going to actually subtract here. We want to subtract 49 from 625. Well, if I subtract 50 from 625, that's 575, so I need to subtract 1 left, so that's 576. And b squared equals, so now b is equal to the square root of 576, which I think comes out to 24. So my answer here is, the missing side is 24. All right, let's try some more. Problems are all pretty similar. You just have to figure out which way you're looking for the answer. And if you just substitute in the values and know which side is A, which side is B, and which side is C, you should be all right. So on this problem, you're supposed to keep off the grass, but if you ignore the sign and want the shortest distance from point A to point B, that would be this distance right here, going to the corner, like that. Okay, now to get that, we can just do this is a right angle there. So we have the two legs of the right angle, which are 9 and 12. We need the hypotenuse. Let's call that C for now. So we have a squared plus b squared equals c squared again. And a is 9. We could substitute 9. You could actually put 12 for a too. That wouldn't matter. And then 12 goes there. And 9 squared is 81. 12 squared is 144. And 81 plus 144 is 225, I believe. And then we need to do the square root of 225 to get C, which is 15. Now we can answer A. If we go around and obey the sign, we're going to have to do 9 plus 12, which is 21. If we ignore the sign, we get to just walk the square root of 225, which is 15 meters. So we're saving 6 meters by ignoring the sign and cutting across. This next problem has to do with baseball diamond. And I like it enough that I think I'd rather do it in class with you. So if you want to go ahead and do it now, that's fine. Just pause. All right, let's look at another one here. Caroline and Trevor are flying a kite. Caroline is holding the kite and lets out 80 feet of kite string. Trevor is standing 25 feet from Caroline and is directly under the kite. Caroline is holding the string 3 feet above the ground. How far above the ground is the kite? Okay, so if you look at this deal here, if Trevor is directly above that, then we have a right angle right there. And what we want to know is how far above the ground it is. Now we have 3 feet here, but this distance right here from Caroline up to the kite in a vertical direction, we'll just call that h for height. Okay. Then we can use Pythagorean's theorem here because we have this 80-foot length there, and we have 25-foot length here. And so our two legs, so in this case it's a squared plus h squared, height is equal to c squared. And a squared is this distance right here, 25. H's are unknown. C is the length of the string, 80. So we can just do 25 squared, which is 625, plus h squared, and that's equal to 80 squared. And then I can do subtract 625 from both sides. And I get h squared is equal to 5,775. So that means h is approximately, now we're going to use a calculator to find that, 75 point something, if we round it to the nearest foot, which I think is accurate enough for this. It's about 76 feet. And so how far above the ground is the kite? It's 76 plus the extra 3 feet that Caroline is there. Because she's holding the string 3 feet above the ground already. So that's 79 feet. Okay? And my explanation is our work over here. All right? Let's try this next problem. Safety regulations state that a wheelchair ramp cannot be too steep. Suppose that for every 1 foot a wheelchair ramp rises, it must cover a horizontal distance of at least 11.5 feet. All right, the ramp is being built to a restaurant entrance that is 2.5 feet above the ground. So, so what we have here is we're going to make a ramp, and we'll just draw a little picture. It always helps to make a picture when you're doing right triangle. The entrance is 2.5 feet above the ground, so we're going to put that right there. Okay, and we want to know how much horizontal distance this ramp requires. Here's our information. For every 11.5 feet that we go horizontally, we go up 1.5 feet. So we need 11.5 feet for 2.5 feet. So we can just multiply 11.5 times 2.5 to figure that out. and that's 28.75 feet. So that's our two legs, 28.75. And now to find out how long we should make this ramp, we can just use Pythagorean theorem. We can do, and that's this question right here. So our horizontal distance we need is 28.75, and our work for that is right here. And now I'm going to do a squared plus b squared equals c squared to find the hypotenuse, which is our ramp length there. And so I'm going to do 2.5 squared plus 28.75 squared, and that's equal to c squared. And if I square this and add them together, I get 832 points, let's just say 0.9. And then to find c, I need to do the square root of 832.9, which is about 28.9 feet. One thing you should do when you're doing these problems is check your answer and make sure it makes sense. Knowing that the hypotenuse here is the longest part of the triangle, your answer should be a little bit longer than either of these two sides. So if you got an answer that was shorter than those, then you know that you were wrong. We're good there. Also, like on the last problem here, our height is one of the legs, so our height should actually be less than that length, 80. So that's one kind of check you can do. And notice we got 76 there, so that's a good check on that. All right. Let's do one more problem. I'll just get you started on here, and then you can kind of see how it works here. But it says in this problem, find the values of C and H. Well, I think C is this distance here. I'm not sure. To find the total distance there, you have the two legs of that right triangle, so you can do 5 squared plus 12 squared is equal to C squared if that's the total length. But you're going to have to do something a little bit different to get H. Now, one thing you might notice is that you have a couple of similar triangles in here. You have the little triangle, and I'll just label this here with the hypotenuse of 5. All right, and then you have a medium-sized triangle right here, and I'll draw that next. And on that one, we know that the hypotenuse is 12. Oops, I labeled that wrong. That's 12. And then the last one is the whole triangle. And I'm going to draw this way, the long way. The biggest triangle, which is the two little triangles added together. And that hypotenuse is this one, C. So, so we can compute that hypotenuse. 5 squared is 25, 12 squared is 144. If we add those, we get 169. And so C is equal to the square root of 169, which is 13. So that's 13. All right, now we know that these parts are all similar. These triangles are similar because they share angles. And if they have the same angles, then the definition of similarity is that all three angles are the same, which we have here. So now I can do something to try and figure out the missing H. Well, H is this leg on this triangle, and it's this leg on this triangle. And C is my 13 here. So I can actually set up a proportion here. And my proportion is this. This long leg over this hypotenuse from my biggest triangle is equal to H, the long leg, over 5 from my little triangle. And I can use that proportion right there to find H. Just do 12 times 5 divided by 13. All right? That's going to be the end of this, and we'll do the rest in class. See you tomorrow.